Okay, so picking up where we left off, we've introduced the synthetic division, and so now we're going to get to see a little bit more about it, but it's going to be still about kind of practicing the process. So first thing we're going to talk about is this thing called the remainder theorem, and what that's going to do is give us a little insight of what that remainder represents whenever we're talking about polynomials in the division. So right here, when dividing a polynomial by, let's say, x minus a, where a is going to be some number, right? The remainder will be the answer if you were to evaluate the function at that value right there, basically the solution to that factor right there. So here's our example right here. So if we have this function right here, 3 x cubed plus 8x squared plus 5x minus 7, and we're going to use the remainder theorem to find f of negative 2. So what that represents really is as a factor that would be written as x plus 2. Because when you take this and solve it, the solution to this factor would be negative 2. And so if you were to evaluate the function at negative 2 right there. So by the way, that will be the magic number though, because you take that, set it equal to 0, and solve in order to find your magic number for the process of doing the synthetic division. So here we go. So I have the coefficients here, 3, 8, 5, and negative 7. And so we're going to use negative 2. And so we drop the first number and you multiply, add, multiply, add, multiply, and add. So this negative 9 actually represents, that's the remainder, but that also is the value if you were to plug in negative 2 into the function right here. And so I will just go ahead and prove it to you real quick. And so if we were to do f of negative 2, that would be equal to 3 times negative 2 to the power of 3 plus 8 times negative 2 squared plus 5 times negative 2, and then we have that minus 7 right there. Well, negative 2 to the power of 3 is negative 8. Negative 8 times 3 is negative 24. Then negative 2 squared is positive 4. 4 times 8 is 32. And then 5 times a negative 2 is going to give us a minus 10. And then we have that minus 7 right there. And so then we'll go ahead and add these together. So let's see, negative 24 plus 32 would be positive 8. 8 plus negative 10 is negative 2. And then negative 2 and that minus 7 combined together to give us negative 9, which was the same value as our remainder right there. So as you can see, synthetic division actually was a lot faster than me plugging that in right here for the x values. So kind of interesting, but the one thing I do want to point out though is this function notation right here, f of negative 2 written as a factor, that would be x plus 2. Okay, as a factor it would be x plus 2. Um, okay, so once again, this is kind of more about just getting some practice on using that synthetic division process. And so if you look right here, it says use synthetic division in the remainder theorem to find the indicated function value. So technically you could just plug 4 in for x, okay? But what we're going to do is we're going to use synthetic division. Now, be careful here because I'm missing the x squared, so I am going to need to put a 0 in there. If I don't, then it's not going to come back correct. So I need to put in a 2, a 0, then negative 7, and 5. Okay, so starting at your highest power, count down, and if you're missing any, you have to put in a 0 for that spot. And then now I'm going to use 4 is going to be my magic number right here. And then what we'll do here is we'll drop the first value and then just do your process. 2 times 4 is 8. Add those together. 8 times 4 is 32. Then we'll add those together. Let's see, that should give us what, 25. 25 times 4 is 100. When we add that together, it's going to be 105. And so that is my answer. F of 4 is equal to 105. So that's my answer. All right. This next one, yes, we have a fraction, but it should come out fairly clean. It should be pretty nice. So first thing we'll do here, let's see, we've got 2x to the power of 4, then we have a power of 3, 2, 1, and then my constant. So I don't have any fillers I have to put in like I did on example A. So let's go ahead and make this. So let's see, we're going to have a 2, a -5, a -1, a 3, and then a 2. And then the magic number we're going to be working with is -1/2. Okay, so like I said, I know it's a fraction, but it really shouldn't be too bad. And if you really want to, you can use a calculator. But let's see, we're going to drop the 2. Then basically when I multiply by half, basically I'm going to cut it in half, and then it's negative, so there's going to be a sign change. So basically just cut it in half and change the sign. So half of 2 is 1, and then change it to a -1. Then combine this together, -5 and -1 combine to -6. Then half of that would be -3, but because I'm multiplying by a negative, I have to change it to +3 right there. Then once again, add those together, that's a 2. Then take half of that and change its sign, so that'd be a -1 again. Then -1 plus 3 is 2. Same thing again. Then half of 2, and then change its sign, so it's -1. Add that together, and I get +1. So that was my remainder, and that is the solution to f of -1/2. F of -1/2 equals 1. That's my answer right there. All right, so that's the remainder theorem. It gives you a little idea of what that remainder represents, and that kind of leads us to our next thing that we're going to look at, which is going to be the factor theorem. So the factor theorem, so if we let f of x be a polynomial function, if f of a, so the value that you're evaluating the function at, is equal to 0, then that would mean that x minus a is a factor of the function f of x, okay? And so it will probably make a little bit more sense once we actually use a real example with numbers. So let's see, therefore, if synthetic division yields a remainder of 0, then we can factor the polynomial into the product of the divisor and the quotient. So I have an example here with just regular numbers we're a little bit more familiar with. So what we're doing here, it's basically 20 divided by 4 is 5, and there is no remainder, right? The remainder would be 0, right? There's no remainder. 20 divided by 5, I'm sorry, 20 divided by 4 is 5, and there's no extra remainders. So what this means is that 20 is equivalent to the divisor times the quotient right there. That's what we meant by this, the divisor and the quotient, the product of those two. So the divisor was 4, the quotient was 5, so their product is equivalent to the original value that was being divided. So that's going to kind of be the same idea with the synthetic division. If we get a remainder of 0, what that means is that the divisor, which in this example right here I have down below, the divisor is x plus 2, and if the quotient is, or if the remainder is 0, then if I take this and multiply it by the quotient, it would be equivalent to the original polynomial that's getting divided. Now, we're not really asking you to go that far on these first couple of examples, but eventually that's where we are headed with this, okay? All they're asking us to do here is for each polynomial below, find the remainder of f of x, which is going to be the numerator, divided by x minus a, which is right here my denominator, to determine if x minus a is a factor of the function f of x. So what we want to do here is figure out the remainder. The remainder is, and then from there we can determine whether x plus 2 is a factor or not. So let's go ahead and get this lined up. So first things first, I got to take the divisor, set it equal to 0, and solve. And so we're going to get x equals -2. That's going to be that little magic number I'm going to work with in a moment. Now let's see, my coefficients are 1, -9, 21, another 1, and then -30. And I don't have anything missing, so that's good. So let's see, 1, -9, 21, 1, and negative 30. And then the number we're going to use is negative 2 right here. So we drop the first number, and then multiply, put it in the next column, add. Multiply, positive 22. In the next column, add it together, we're going to get 43, it looks like. And then let's see, we're going to multiply. See, we're going to get negative 86. Add that together, that's negative 85. I can already tell this is not looking like we're going to get a remainder of 0, but let's just keep going. So we multiply that together. Let's see, this can give us 170. We add that together, and we're going to get negative 140. So that is the remainder right there. The remainder is negative 140. And so since that's the case, what that means is that this is not a factor of the numerator polynomial. It's not a factor of the polynomial being divided. So x plus 2 is a factor of the function. False, it is not. I have to get a remainder of 0 for that to work. So let's try another one. Maybe example B will give me a remainder of 0. All right. So here we go. We'll start off by taking this, the divisor, set it equal to 0, and solve. So our magic number we're going to work with here is going to be a 1. So we'll go ahead and list the coefficients for here. And once again, I don't have anything missing. So let's see, we got a 1, a negative 12, a 49, a negative 78, and a 40. And we make our half rectangle. And I'm going to put 1 right there. And so we'll drop the first one, multiply, put it in the next column, add together. Multiply, put it in the next column. Let's see, we'll add that together. That should be 38. And then we'll multiply that together, put that in the next column. We add that together. That looks like it's going to be negative 40. Then negative 40 times 1, and then put it in the next column is negative 40. And I got a remainder of 0. So bingo. So if you get a remainder of 0, what that means is that x minus 1 is one of the factors of the polynomial that's getting divided. So let me kind of explain that to you real quick, because this is what we're going to kind of get into on the next page. So, and this will actually kind of hopefully make a little bit more sense once you see this. So what I'm going to do is take the quotient. That's what the result was from the division. So this would be x to the power of 3 minus 11x squared plus 38x and then minus 40, right? And then I didn't have a remainder, so I don't have to worry about tacking anything on, right? So this is the quotient, okay? And so if you look back up here, what we say? I gave a little example right here. We did 20 divided by 4 equals 5. So in this case, what I have written in blue here is basically kind of like my 5, right? And then if I were to multiply that by the divisor, that'd be equivalent to the original polynomial that was being divided. So if I were to take this in blue, and if I were to multiply it by the divisor, which was x minus 1, right here, this is actually equivalent to this up here. It's equivalent. It's just been factored now. So this right here is the same thing as I have up here. We actually factored it. And so that's really where this is going. Is our goal is going to be able to take these polynomials and try to figure out all their factors and then ultimately find the solutions to the polynomial. So that is where we're headed. So I'm going to go ahead and stop here because the next video, that's where we're going to start that process.